Welcome back to the Math Professors. Today I'm going to do basic integration techniques for double integrals, and our focus is going to be U-Substitution. So if you like this free content and you want to help us grow, please consider liking, subscribing, and sharing. So we're going to go after this. I want the double integral over the region of xy e to the xy squared over the area. So the region is going to be 0 less than or equal to x less than or equal to 2, and then 0 less than or equal to y less than or equal to 1. So this video is really showing us, if I'm going to do U-Substitution, we have to be careful what we integrate with respect to first. Do I want to do it with respect to y first or x first? So what I know is that U-Substitution is really good for compositions, and I see e to a function. So I'm assuming that this u is going to have to be equal to xy squared. So now what I'm going to have is, the double integral over e to the u. Now, what I can also see is that I have an xy in front. So when I do my du, I'm kind of hoping that I get an xy back. So when you do your du, I need to know, what am I going to take the derivative with respect to first? If I'm going to do it with respect to x first or respect to y first? Well, if I take the derivative with respect to x, I'm going to get a y squared. But if I take the derivative with respect to y, I'm going to get a 2xy. So I can see that I'm going to want to have to do this with respect to y first. So du dy is going to be equal to 2xy. So what I know is I'm going to want to have to integrate this with respect to y first. So we'll fix this in a minute here. So this is going to be equal to xy e to the xy squared. I know I'm going to want to do dy first and then dx second. Y ranges from 0 to 1. And then x is going to range from 0 to 2. Remember that inside is going to be your y's and outside will be your x's. All right. Now let's turn this into u's using this thing right here. So du, sending the dy to the other side, is going to be equal to this. And I also need to substitute, if I'm going to turn this into the integral of e to the u, if this is going to be the integral from 0 to 2 of the integral, we'll get to the bounds in a second here, of e to the u, I need to turn these things into the same variable u, and I can use this to do that. So we need to figure out what is u of the lower bound, which is going to be equal to 0. Well, plug it in. Remember, this is at y because we're doing the y's first. So this is going to be x times 0 squared, which is going to be equal to 0. And also, if I want to find u of the other bound, which is going to be 1, so plug it in y equals 1 here, this is going to be x times 1 squared, which is going to be equal to x. So instead of going from 0 to 1, now it's going to go from 0 to x. Now I also know that that this du is going to be equal to 2xy dy, but I don't really need two of these. What I really need is just an xy dy, so I can say 1/2 du is going to be equal to xy dy. So that means I'm going to have this is your e to the u, which happens to be over here, xy squared, and then xy dy becomes 1/2 du. And don't forget our dx. Now I'm going to integrate with respect to u first. So the integral of e to the u is e to the u. So this is going to be equal to the integral from 0 to 2 of 1/2 e to the u evaluated at the bounds, which is going to be 0 and x, dx. So evaluating this at x and also evaluating this at 0, this is going to be equal to the integral from 0 to 2 of 1/2 times e to the x, let's do this in parentheses, minus e to the 0. Now remember, this e to the 0 is equal to 1, so I'm just going to write this as 1, and then we have dx. Now this is nothing more than a Calc 1 problem. I can pull out that constant of 1/2, and then I can integrate these. So this is going to be equal to, the integral of e to the x is e to the x, the integral of -1 is going to be minus x, and then evaluating this at these bounds, which is going to be 0 and 2. So plugging in 2 first is going to give us 1/2. This is e to the 2 minus, 0, minus 1/2, and then I'm going to have e to the 0 minus 0. That is not right. That should have been 2. Okay, finishing this off, this is going to be equal to 1/2, just they both share a factor of 1/2. So I'm going to have e squared minus 2, also minus, pulling out this 1/2 is going to be minus 1, so this is going to be minus 3. So again, please consider liking, subscribing, and sharing. Thank you.